If you look at this question, students, this is a question asked in the IIT exam, okay? Alpha not equal to 0, beta not equal to 0, and there is a function which is defined f of n is equal to alpha to the power n plus beta to the power n. So this only means to say that f of 1 can be written as alpha plus beta, is it right? F of 2 can be written as alpha square plus beta square, is it not? And f of 3 can be written as alpha cube plus beta cube, and f of 4 can be written as alpha to the power 4 plus beta to the power 4. This is the meaning of it. So if you now see how to write this, I can write this as 3. 1 plus f of 1 can be written as alpha plus beta, 1 plus alpha square plus beta square, is it not? 1 plus alpha plus beta, and 1 plus alpha square plus beta square, and 1 plus alpha cube plus beta cube, is it okay? 1 plus alpha square plus beta square, 1 plus alpha cube plus beta cube, is it right? And then 1 plus alpha to the power 4 plus beta to the power 4. Okay, let us concentrate only on this part now, only on this part. We will call this as delta, is it okay? After that we can compare on both sides. Now I can further write this 3 can be written as 1 into 1 plus 1 into 1 plus 1 into 1, if you can agree, because there is a property of determinant which will allow you to split the determinant, right? Similarly, I can write this as 1 into 1 plus 1 into alpha plus 1 into beta, is that right? Plus and 1 into 1 plus 1 into alpha square plus 1 into beta square. I can always write it like this. Similarly, 1 into 1 plus 1 into alpha plus 1 into beta, is it not? 1 into 1 plus 1 into alpha square plus 1 into beta square. And similarly, 1 into 1 plus 1 into alpha cube plus 1 into beta cube, is it okay? 1 into beta cube. 1 into 1 plus 1 into alpha square plus 1 into beta square. And 1 into 1 plus 1 into alpha cube plus 1 into beta cube. And 1 into 1 plus 1 into alpha to the power 4 plus 1 into beta to the power of 4. Is it correct? Now we can write this value of delta as this value of delta can be written as now if you see correctly, see this part I have to split. I can write, if I want to get 3, I can write 1 into 1, look here, 1, 1, 1, first row, multiplied with first column, 1, 1, 1, I am getting 3, right? 2 determinants I'll split and write. Similarly, I have to get 1 multiplied by 1 will be 1, 1 into alpha will be alpha, and this part will be beta, is it right? Similarly, 1, alpha square and beta square. See, I am able to realize this. First row. Now second row multiplied by the first column. So I can write this as 1 alpha beta, is it not? 1 alpha beta. 1 into 1, 1 plus 1 into alpha. See here, if I consider the second row like this, 1 into alpha, 1 into plus 1 into beta, is it right? And here 1 into 1, 1 into alpha square, 1 into beta square. Similarly, 1 alpha square and what is it? Beta square. Correct or not? So ultimately this is basically a matrix, right? Whose determinant is to be found out. Now if I try to write this, consider this in the form of a matrix, I am able to realize this. 3 cross 3 matrix, multiplication of 2, I am getting back the same things here. Now because this is the part of the determinant by property, value of transpose of the determinant is equal to delta. We know this property, right? So that you apply here. So I can write delta is equal to determinant of 1, 1, 1, 1 alpha beta and 1 alpha square beta square. And here you take the transpose 1, 1, 1, then 1 alpha alpha square and 1 beta and beta square. Is it right? 1 beta and beta square. So I can write delta is equal to 1, 1, 1, 1 alpha beta and 1 alpha square and beta square, the whole square. Is it right? Because these two are the same determinants. All right. Now for time being, we'll consider, to solve this problem, we'll consider this part, now this determinant. Now I can apply this whole square is there for time being. Let us consider let k is equal to, let the value of the determinant be k. I can we'll take the value of the determinant as m. Okay, let m is equal to 1 1 1 1 1 1 1 alpha beta and 1 alpha square and beta square. Is it okay? 1 alpha and beta square. So we can apply the elementary transformation, students. C2 forms C2 minus C1 and C3 forms C3 minus C1. Is it okay? C3 minus C1. So I can say m is equal to 1 1 1 0 alpha minus 1, okay, and alpha square minus 1, 0 beta minus 1 and beta square minus 1. Now if you carefully look at this part, slightly lengthy problem this is. If you carefully look at this part now, expansion of this determinant, so expand along row 1. When you expand along row 1, you will get 1 multiplied by alpha minus 1 into beta square minus 1 minus of beta minus 1 into alpha square minus 1. Is it right? Alpha square minus 1 minus 0 into anything is 0 plus 0 into anything is 0. So I can write m is equal to alpha minus 1 into beta minus 1 into beta plus 1 minus of beta minus 1 into alpha minus 1 into alpha plus 1. So m is equal to, I can take out alpha minus 1 common and I can take out beta minus 1 common. So I'll be left with the beta plus 1 minus of alpha plus 1, correct or not? So m is equal to alpha minus 1 take out 1 common, 1 minus alpha, beta minus 1 take out 1 common, 1 minus, take out minus sign common, minus into minus becomes plus, and here this part will be beta minus alpha. Okay, but your delta will be m square, right? Delta will be m square. Delta is as good as writing m square, which is nothing but 1 minus alpha square into 1 minus beta square into beta minus alpha the whole square can also be written as alpha minus beta the whole square. Now if you compare with the question, compare with the k into 1 minus alpha square 1 minus beta square into alpha minus beta the whole square, compare with delta. So that value of k will be equal to how much now? The value of k will be equal to 1. This is the answer to the question.